Good day, viewers. Thanks for having me here. My name is Mr. Frank, and I'm your physics, chemistry, and mathematics teacher. But this afternoon, we'll be going to discuss one or two in chemistry. And as you can see on the board, we have empirical and molecular formula. Before you will be able to answer questions on this kind of question, you need to know the meaning of the thing that is written on the board. So what is empirical formula? Empirical formula is defined as the simplest formula of a compound that shows the numbers of atoms that is present in a molecule of that compound. While a molecular formula is defined as that formulae of the compound that shows the actual numbers of molecules present in the molecules of the compound. But what you need to understand is that while this one is the simplest formulae, this gives the actual numbers of molecules that is present in actual numbers of atoms that is present in any molecule. So let's try to attempt this question. An hydrocarbon containing 92.3% by mass of carbon, the relative molecular mass of the compound is 78. Calculate its empirical formula. Second question, molecular formula. And the third question is name the compound and write the structure. So first thing is, what is an hydrocarbon? An hydrocarbon is defined as a compound containing only two elements, which is hydrogen and what? And carbon. So when you understand that, I believe you should be able to answer questions like this. So as you can see, you are given the proportion by mass of carbon, that is 92.3% of carbon is present in that hydrocarbon. So to solve this, the carbon takes the proportion of 92.3%. So which means the remaining proportion will go for hydrogen, which is the second element present in hydrocarbon. So we are going to have 100 minus 92.3, which is going to be equals to 7.7%. Are we together now? So the next thing is, how do we intend to find the empirical formula? So the steps taken, I'm going to be showing you as I'm working out the question. Number one thing, you need to draw this kind of table. Okay, let me draw it there. This table. You need to, the first thing is the elements that makes up the compound. And what are the elements? Carbon. Then the hydrogen. So what is their proportion or composition? Proportion by mass. The proportion of carbon given is 92.3. 92.3. While that of hydrogen calculated is 7.7. So the next thing you are going to do is to find the proportion by mass of each of the elements given. So let's find proportion by mass. So how do you get the proportion by mass? Proportion by mass is the division of each of the values, each of the proportion by their relative atomic mass. So, and the relative atomic mass of carbon is 12, and that of hydrogen is 1. So let's get the proportion by mass of carbon in this, in the hydrocarbon, so which is going to be 92.3 divided by 12, and that of hydrogen will be 7.7 divided by 1. So let's pick up our calculator and calculate the value. So 92.3 divided by 12 is 7.7. While that of hydrogen also is 7.7. So the next thing is to, after you have gotten your proportion by mass, the next thing you are going to do is to divide by the smallest ratio. Divide by the smallest. So as you can see, we have 7.7, we have 7.7, so which are of the same value. So we can say that any of them is the smallest. Except you have equal value, so let's divide everything by 7.7. 7.7 divided by 7.7. 7.7 divided by 7.7. And then we are going to arrive at the simplest ratio. 7.7 divided by 7 is 1. 7.7 divided by 7 is 1. So therefore, the empirical formula is equals to C. So we can see that we have one atom of carbon, one atom of hydrogen, 1. So that is the empirical formula, so which is CH. So the next question is to find the molecular formula, which is the actual, the formula of this hydrocarbon that will show the actual numbers of the atom that is present in the molecules of this hydrocarbon. So let's find the second one. You are given that the relative molecular mass of that hydrocarbon is 78. So relative molecular mass, let's represent that by RMM. Relative molecular mass equals to 78. So we can then say that to find relative molecular mass of any compound, you sum up all the relative atomic mass that is present in the what? In the atom. The compound. So therefore, we can say CH multiplied by the actual numbers of atoms equals to the total relative molecular mass 78. Why this is not showing the actual numbers of atoms, it's only showing the simplest ratio. So the actual numbers of atoms present in that molecule is the molecular formula. So let's represent N by the actual numbers of atoms. So we can have the relative atomic mass of carbon is 12, and that of hydrogen is 1 multiplied by the actual numbers of atoms, which is going to be equals to 78. Now 12 plus 1 is equals to 13. N equals to 78. Divide both sides by 13 so that you can get your N. 13 divided by 13, N will be equals to 6. So we can then conclude that the actual numbers of atom N is 6, and then the molecular formula equals to CH multiplied by its actual number, which is CH, actual numbers of atoms 6, which you can say that this is C6H6. So this is the molecular formula of this hydrocarbon. Well, as you can see, so number 3 now. Name the compounds and write the structure. As you can see, C6H6 is benzene. So because benzene is an aromatic compound, what are aromatic compounds? They are compounds that contains benzene and other benzene-like structures. According to August Kekule, the structure of benzene is hexagonal. So as you can see, we have 6 carbon, hexagon, 6 carbon, 1, 2, 3, 4, 5, 6. Now, and carbon is tetravalently bonded. So we have 6 hydrogen. So this is 1, 2, 3, 4. Hydrogen 1, 2. So let me add 1 to this. That is 1, 2, 3, 4. Okay, hydrogen. Okay, hydrogen. 1, 2, 3, 4, 5, 6. So everything is balanced. So you can count Carbon is tetraplegic, so we have 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So this is the structure of the compound. Thank you for listening, and do well by following my page. Thank you. God bless you.